everyone. Thank you for joining us today. We're just going to give everybody a couple more minutes to log on, and then we'll get started with the presentation. All right, let's go ahead and get started today. Hello and welcome to Get Ready for Title 24 Updates. We have Adam Sweat with us today, our Regional Sales Manager. Adam, thanks for joining us. Before we get started, we have a quick disclaimer for everybody. This presentation is intended to be informational and used as a resource and is subject to change depending on new or updated policies, which we do not have any control over. Some housekeeping items. This webinar will be available to all registrants in the next couple of days, and we encourage all of you to follow us on social media outlets in order to stay up to date with company news and events. So let's get started with the agenda. We're going to give you a summary of Title 24, review some of the upcoming changes going into effect on January 1st, 2017, provide you with our solutions, go over some of the benefits, and finally give you some resources and leave time for questions and answers at the very end. I'll pass it over to Adam now.
Thanks, Gulzar. Hi, everybody. Like Gulzar said, I'm going to be talking a little bit about the Title 24 changes today. For those of you that don't know, Title 24 is California's Building Standards Code. Part 6 specifically is the California Energy Code, which pertains to energy efficiency requirements. These codes were created by the California Building Standards Commission in 1978 in a response to some legislative mandates to reduce California's energy consumption. The standards, they get updated about every 3 years by the CEC to allow for the consideration and incorporation of new technologies and efficiency technologies that are moving into the marketplace. In general, the code is going to parallel with ASHRAE and take a lot of its cues from ASHRAE, and that's what a lot of the different code cycles look at, is what changes were made to that throughout the year. The way that they look at reducing the total energy requirements for the state usually revolves around lighting power allowances in watts per square foot, and then using advanced lighting controls throughout the facilities. So the new code cycle for Title 24 is going to go into effect on January 1st of the coming year. The Energy Commission is going to put a strong focus this year on solar technologies, some additional storage methods, some renewable energy technologies, and reducing plug loads. There's also a big push by the California Energy Commission to continue to improve energy efficiency standards to get the state closer to a zero net energy goal. They do this through regulations on indoor commercial and residential lighting and building loads. So some of the changes that we're going to talk about today include the triggers and alterations, some of the power adjustment factor changes, multi-level lighting control changes, occupancy control changes, and some egress lighting requirements and power density changes. So the first thing that we want to cover is the luminaire component modifications. There are a couple of changes from last year's code cycle to this one regarding luminaire modification in place. The first one is just a clarification of the language of the code that a bulb and a ballast have to be removed or replaced or altered to count as a modification and trigger the code. What this really means is that certain types of LED tubes, certain types of retrofit kits are going to trigger the code and require additional controls. They also raise the threshold of modifications from 40 fixtures in a space to 70 fixtures in a space, or 10% of the total square foot or total number of fixtures of the space within 1 year. They added the per year requirement to allow for changes throughout time of piecemeal sections of a facility. In general, the space is going to be defined as a functional area inside of the facility or an area that's divided by vertical walls. So for the entire luminaire alterations section, there was an exception added to this year's code cycle that should make things a little bit easier going forward and getting things through the Title 24 permitting process. It'll also help move some projects along a little bit faster with the end goal of getting more energy efficiency projects completed. This is going to allow for certain controls requirements to be bypassed when energy reduction thresholds are met. So as you can see, if the replacement of the fixtures reduces the total power consumption of the lighting by 35% or more in an industrial space, it's going to be exempt from some additional multi-level controls and occupancy requirements. In office spaces, that threshold is going to be set to 50%. So what that's going to allow for is more projects to get pushed through, more energy efficiency goals to be met, and people to stop sort of being hung up on making changes because of Title 24 and the additional restrictions that puts in place. There are also some changes to the lighting wiring section of the code. Mostly we're talking about wiring and infrastructure alterations. In general, the code is a little stringent. It's only going to be requiring compliance with the control strategies if new circuits are going to be created, replaced, or modified, or if we're looking at new panels for either power or for lighting controls installed in the lighting circuits. They kept the requirement for multi-level controls and automatic daylighting controls for these situations, but they took out the requirement to add demand response controls if you're just going to be changing the lighting wiring or the infrastructure inside of the facility. Made some For those of you that are familiar with the 2013 code, power adjustment factors are listed as different control strategies. Power adjustment factors are the ability to go in and increase the overall lighting power density or your number of watts per square foot inside of the space if you meet or exceed the requirements of the control strategy. So they made some changes to what's allowed for these power adjustment factors in this cycle of the code. They took away power adjustment factors for partial on and manual dimming. In general, I think they took those away because those are manual controls and not automatic controls. They also added some power adjustment factors for institutional tuning and daylight harvesting. They have specific factors that can be used as combinations or can be used as individual strategies. Make sure that when you're going through and determining what your lighting power density allowance is for your specific space, that you check the code and you look at the different adjustment factors that you're allowed. In general, digital lumens is going to be significantly below the required lighting power density. So this is always an opportunity to look at savings by design incentives that are offered by the major utilities, which allow for additional incentives when you design above and beyond the requirements of the code. So if you're able to reduce the lighting power density of the space beyond what's required, taking into account your power adjustment factors, there's some additional incentive money that you could be getting for that. There was also a change to the multi-level lighting controls. In the previous code cycle, it's required to choose another control strategy when you're employing multi-level lighting controls in a layered approach. This cycle, they chose to simplify the code a little bit and remove the requirements in most situations. Every technology has a different requirement for multi-level lighting control, LED, fluorescence, etc. LEDs specifically are going to require 10 to 100% continuous dimming. Other technologies are a little bit more complex in the way that they employ their dimming strategies, so make sure that if you're doing a combination retrofit using LEDs and fluorescence, that you check the table and you verify what the multi-step requirement is for that specific technology. There was also a change made to the egress lighting inside of the space. It was modified and provided with some exceptions based on feedback from designers on the last code cycle. In general, you're looking at a reduction of lighting power densities in the space, an increase of lighting power densities in the space, and a removal of some of the existing control requirements. For example, we're talking about up in any area they now have the ability to go up to 0.2 watts per square foot, and there's no area control requirements if you meet that threshold. If you can get below 0.1 watts per square foot, you don't even have to meet the automatic shutoff control requirements. The previous code cycle had that at 0.05 watts per square foot. And that's talking about just the egress lighting inside of the space when we're only using the batteries. Different technologies are going to handle that differently. For digital lumens, that's going to be when we're using our battery pack only. So it will be the nameplate wattage data for the battery pack. Now, if egress lighting falls within a daylit zone or a secondary daylight zone inside of the space, automatic daylight controls are going to be required if the code still requires that measure is employed. So we've covered some of the major changes in the code that I wanted to look at. But in general, I want to look at how digital lumens can really meet some of the Title 24 requirements that we see in the code, both in 2013 and in 2016. So what we've done here is we took the Energy Code ACE trigger sheet from the website on the resources section, which gives you sort of a snapshot of what's required for indoor lighting controls and lighting control devices in different applications. So if you look at the first two lines here, luminaire additions and luminaire alterations, we can see that lighting control devices and systems are going to be required in almost all situations. Indoor lighting controls are listed in the next column, which then gives you the strategies that need to be employed as mandatory controls inside of the space. So we're looking at luminaire alterations and luminaire additions, which are going to trigger the multi-level controls, the daylighting controls, the task tuning, and in some cases, the demand response controls. For different types of alterations, as you can see going down the chart, different levels of control are going to be required. Again, this is for the 2013 code cycle. We expect the Energy Commission is going to be releasing another 2016 trigger sheet prior to the implementation of the code in January. So look for that to be coming along. We're also going to provide you with a link at the end of the presentation so you can get to that website and you can see these trigger sheets for different applications. So let's take a look at each of these methods and see how DL would deploy a system to meet these requirements. So we're going to look at the measures. We're going to look at different ways to employ those measures and then how we would do that with Title 24 with digital lumens. So the first one I want to take a look at is multi-level control. Multi-level control is going to be required in most situations throughout a facility. The traditional way of meeting this requirement is going to be using relays and occupancy sensors inside of a facility with fixtures grouped into different sections. This is going to cause you to control fixtures on a very rudimentary level. We're going to be looking at individual functional groups inside of the facility and setting them to operate in a certain way all the time. It's a very rigid and sort of a harsh way of doing occupancy control inside of the building. It's going to also provide you with some harsh transitions from space to space. For example, if you have a space that's being controlled with an occupancy sensor adjacent to a space that's not, that happens frequently in manufacturing facilities and warehousing facilities that have both types of spaces in them. The manufacturing facility part is going to be all on, and the warehousing space is going to be controlled by sensors. So between those two spaces, there's going to be a harsh transition of all on to off or all on to partial off, along with the additional blinking and flashing of lights from their active state to their inactive state. When we look at doing this with digital lumens, it's going to be a much different approach. We're going to look at doing an individual fixture control and an individual fixture dimming profile for every fixture or every functional space inside of a facility. For example, we can look at manufacturing. We can take an active and an inactive level of maybe 100% on when there's people in the space and the fixture is sensing occupancy, down to maybe 70% when there's no motion sensed during daylight hours or during manufacturing hours. Then we can set the time that it takes for that trigger to happen. So say after 1 minute or 2 minutes, of no motion sense, the fixture can transition from the high power to the low power. We can also change that transition time. So once the transition begins, we can make it a smooth dim down from 100% to 70% over 10, 20, 30, 40 seconds to make it imperceptible to the people that are actually doing the work inside of the facility. This makes for a much smoother transition between spaces. It makes for less harsh lighting changes, which prevent people from looking up and being distracted by the lighting. And it gives you the ability to maintain the productivity inside of the facility that people are used to without bringing in a lighting control system that's going to cause a lot of issues with personnel. The next one I want to take a look at is daylight harvesting. Daylight harvesting is traditionally done with an open loop system with an upward facing sensor that's placed somewhere near a skylight inside of the facility. That sensor is going to control all or some of the fixtures inside of the facility and turn them off or turn them on based on thresholds that are hit at that sensor. This is going to give a similar effect to what we were talking about with the multi-level control systems. Different sections inside of the facility are going to have lights off adjacent to fixtures that are on, which is going to cause harsh transitions inside of the building. Also, when you're talking about turning groups of fixtures off at the same time, that can be very distracting to workers inside of the facility. It can be very distracting to different manufacturing processes, and it can cause issues with safety and productivity. The other thing that we want to look at here is a lighting quality standpoint. If we look at taking 20, 30, or 40 or more fixtures out of the facility and just turning them off when we hit a certain threshold, we're going to end up with shadowing. It's something that just can't be avoided, right? So we want to look at different ways of maybe employing daylight harvesting inside of the facility and being able to take advantage of the daylight that's coming in so we can reduce the overall energy usage but not sacrifice safety and productivity. So we use a closed loop system which employs a daylight sensor on every single fixture that's downward facing. So we look at the light level at the work plane. We set that light level for a certain threshold when we do the commissioning or the programming of the system, and we maintain that threshold throughout the day. So if we introduce any external light source, the fixture is going to dim. If we remove that light source, the fixture is going to brighten, always maintaining the same level. And we can change the transition times between the dimming and brightening, but in general, it's going to be slow enough that it's not perceptible to the people that are doing the work underneath it. We also build in some additional safeties that prevent the fixture from doing cycling and other things that you've seen in maybe less mature daylight harvesting methods. This gives you the ability to also set different levels for different sections of the facility and provide you with some flexibility in disabling or enabling daylight harvesting as your facility changes and grows. The next one I want to talk about is task tuning. Task tuning is something that people employ in many different sections of a facility. Basically what task tuning is reducing the overall output of the fixture to meet the requirements of the specific task underneath the fixture. In general, this is going to have to be done at the fixture level with a traditional sort of control strategy that people employ, reducing the output of the fixture and keeping it at that level until you go back up to the fixture and make a change. This can be extremely challenging in industrial environments, as we know that ceiling heights in these environments tend to be prohibited from people using ladders. So we look at having to go out on a lift every single time that we need to make a change to the lighting system or change our task tuning strategy. In many facilities that we've been in and we've done business with, they change the way that they employ their space over time. One year we might have a section of the facility that's warehousing only. The next year they may remove all the racking in that section and change it over to production or shipping or some other inspection requirement that may change our task tuning level that we had set in that area. The only way to make a change to that would then be to go up to every fixture in that area and make that change. What we want to do is make it easy to make task tuning changes inside of the facility and allow for a more flexible and easy to use system. So every functional area inside of the Digital Lumen system is going to be set up with its own profile. That profile can easily be changed through our interface at a workstation inside of the facility, on a mobile app that's employed inside of the facility, or individual button stations that we have set up in the facility. This gives you the ability to be flexible and with your changing operations that are happening inside of the building. Finally, I want to talk about demand response. Demand response is something that's sort of growing up right now as the code is required in the last 3 years. Basically, the way that this works is if the utility is expecting high demand, they're going to send out a signal to each facility inside of the affected area, and automatically that system has to reduce a certain amount of lighting load or HVAC load or overall power. This can be pretty challenging for a lot of reasons for the technology side of things, but when it gets to the actual lighting portion, many of the systems that we see deployed today are extremely rigid in the way that they have addressed this requirement. They have specific set daylight or demand response profiles, and they employ those profiles when they receive a trigger, but they're very difficult to make changes to. It goes back to the task tuning argument in it's very stringent, it's very rigid in the way that it's deployed. We look at demand response in the same way that we look at individual profiles inside of the light rules system. We can change them, we can change the number of fixtures that are assigned to each zone, we can verify that we're going to be able to hit the lighting reduction requirements that are in the code, and then we can save those to operate at different levels for different demand response signals. And all of that is going to be totally code compliant. So I do want to point you guys out to a couple of the resources that are available for some of this information on Title 24. It's pretty complex, right? It's not just suggestions. This is actual building code, so actual requirements by law to go and do these things inside of buildings in order to reduce the overall energy usage in California. What we've seen is that as California makes these changes and as ASHRAE continues to make changes, all of the other states are following suit. The coastal states right now are very similar to the way that California does Title 24, and the interior states are starting to adopt some of these same principles. So we want to continue to stay at the front end of good technology that meets all of the requirements but does it in the right way. So here's some of the available resources for you. The California Lighting Technology Center is great. They provide you with training for acceptance technicians and training for building managers. Energy Code ACE has the trigger sheets that we were talking about. The California Energy Commission has a Title 24 PDF of the code. They also have a hotline that you can call and get information about different questions in the code. And also your local utility company is going to be a good resource for you. So as we said, Digital Lumen System allows you to meet all the requirements of Title 24, but it lets you do it in, I think, a more elegant and safe method, keeping productivity in mind. We want to think about lighting sort of differently than other people do. It's a distributed network, right? So we have the ability to think of this as a business operations decision for a building and a facility instead of just a lighting retrofit. When we're going in and we have to add these controls into a system, this with an opportunity to get our system into a facility and employ these different strategies, meeting all of the energy requirements that Title 24 puts forward, but still being safe and productive. It also is going to be able to give you some important business insights that we've talked about in other webinars and other information or other white papers that we have, including occupancy data, energy usage data, traffic patterns, safety information, additional add-ons into light rules. It becomes a building management system or an energy management system inside of your building that can do so many more things than just lighting. All right, so I know I hit you with a lot of different things. Right now, I'd like to open it up for any questions that you guys have. We'll check in the chat box and we'll make sure that we get to your questions here. If there's any questions that I can't answer today, I know a little bit about the code. I don't know everything about the code. If there's anything we can't answer, we'll make sure that we get that answer for you and follow up in a in a blog post. So if anybody has any questions, go ahead and type them in now.
Thanks so much, Adam. We have some really good questions. I'll go ahead and start. First question for you is, where is the easiest place to get a summary of the non-residential changes aside from the resources you just mentioned?
That's a good question. So the best place to get a quick snapshot of the requirements is the Energy Code ACE website. It provides you with a table that's similar to the one that we put into the presentation here. There's also a couple of resources on the California Energy Commission website. One of them is the Title 24 Compliance Manual, which is different than the Title 24 code. The manual provides some amplifications to the code and provides some explanations to the way that the code is written, and kind of goes hand in hand. Now, both of those documents are over 300 pages, so get ready to read a little bit. But there's also some additional companies that are in California that will help you get through these transitions. And if you have questions about that, feel free to contact me, and I'll get you in touch with some of those companies.
All right. Next question. How do Title 24 inspectors verify that code is met?
It's a good question. So part of the Title 24 code includes the workflow that's required for inspections and for getting your occupancy certificate. So similar to the way that the electrical is inspected, or the fire marshal comes out and does your safety inspection, you're going to have what's called a lighting controls acceptance tester or acceptance technician come out, and he's going to verify all of the lighting controls methods that are required per your permits. That can include actual functional testing of individual parts of the control system. It can include visual inspections, and it can include inspections of the actual permits that were applied for. There's also an audit process. Some portion of the number of inspected facilities is going to have an auditor that will come out with the inspector and do an even more in-depth analysis of the Title 24 compliance certificates.
Great. We've got another question. Are permits required for all lighting retrofits?
So that's a tough question because I can't technically answer that without some additional help. Anytime that you're making an alteration to the lighting system, including wiring and alterations to the individual fixtures, it technically requires a permit to be pulled, and Title 24 needs to be met if the triggers are hit for the Title 24 triggers that we showed you earlier. Again, I'm not the state, and I can't tell you to not pull a permit or to pull a permit based on those things, but that is the general idea there.
Great. And the last question, is Title 24 required if we reballast the facility?
So one of the clarifications to the code that I mentioned at the beginning of the presentation is that ballasts and lamps need to be changed in order to trigger the code. If you're just going to be reballasting, that does not require a change or to comply with the Title 24 measures. But if you were to be doing something such as bypassing a ballast and then replacing with LED tubes, that would require that would trigger the code, and you would be required to meet the control requirements of Title 24.
Great. Well, looks like that's all the time we've got. Thank you, everybody, for joining us today, and we'll be sure to follow up with the webinar materials shortly. Thanks again, and have a great rest of your day.